All right, we're going to learn about density, and we're going to show you how to do the homework for today. First of all, what is density? Density has to do with mass, which is like weight, and volume. Mass and volume. Density, you do a little division problem to come up with the answer. But these, if I can get them to stand up, these little tubes here, or they're cylinders, I guess, they are all the same shape and size. Let me get the aluminum one out, because I've been doing this. All the same shape and size, but they all weigh different. This one weighs 17.4. This one weighs 53.8. This one weighs 57.1. And this one weighs 49.7. So steel, copper, brass, aluminum. They have different densities. This one was the heaviest one because the molecules that make up the material are packed together really tight. This one was the lightest one because the molecules that make this up are farther apart. So there's less matter inside the same size. So even though they're the same size, doesn't mean they weigh the same. So also I have this example. These weigh the same. They're different sizes, same shape, different sizes, but they weigh the same. These are the same shape and size, but they weigh different. So the density of something depends on its mass and its volume. Okay, so the first thing on your paper, and I have a paper copy of it, on your paper, it's asking you to calculate the density of the little aluminum thing. So what you're going to do, the first thing you need is the mass of the aluminum. So I'm going to put on here the aluminum on my scale, and it's 17.4. So I'm going to write 17.4 grams right there. 17.4 grams where it says the mass of the aluminum. To find the volume of the aluminum. There's several ways you could do this. You could do a math problem and measure it with a ruler. But I want to show you something, a couple ways you could do this. You could put water, like say 40 milligrams or milliliters of water in a graduated cylinder and drop this in and see how much the water level goes up. And that would work with this. But I want to show you something that's that we'll be using in a lab. This is called an overflow can, and I'm going to fill it with water until it's literally overflowing. I'm going to catch the overflow. I almost didn't get it caught. I'm going to catch the overflow until it's done overflowing, and once it's done overflowing, you can imagine that if I put anything in the water, if I put anything in there, it's going to overflow. So I'm going to take my object, and I'm going to catch the water that it makes this overflow with. So, because when you get in the bathtub, you know, the water level rises up as you put more body under the water. That's because you're displacing the water, and you displace the water exactly the same amount as the body parts that are under the water. Now, to read this, I'm going to have to put my eyeball down at the level, and it's 7. So on my paper, I'm going to put 7 milliliters. 7 milliliters on my paper. So 7 milliliters, like that. So you got 17.4 grams on top, 7 milliliters on the bottom. And remember that milliliters, centimeters square, and cubic centimeters are centimeters cubed and cubic centimeters are the same thing. So you could actually change that milliliters number to, it could be 7 milliliters, 7 centimeters cubed, or it could be cubic centimeters. You could change that because those are all even, all the same thing. Sorry, it's hard to write like that. Okay, so then to find your answer, you're going to take the 17.4 divided by 7. To do that, get out your handy-dandy calculator. You're always allowed to use calculators in science, even on tests. I'm going to take my 17.4 divided by my 7, and I get an answer of 2.429. That's the answer I got. I rounded it up to 4 digits. We'll learn later how to round answers correctly, but I'm going to put my answer. Now, to know what the unit is, or if you look at your problem, your unit is literally in the problem, right there, grams per milliliter. So my final answer is 2.429 grams per milliliter. The next one is this wooden block. Now, we got to weigh it, so I'm going to weigh it. And it says that it's 12.5 grams. So I'm going to write that where it says mass, 12.5 grams. 12.5 grams. Then I'm going to find its volume. Now I could dunk this in water, but it would probably swell, which would make your numbers inaccurate. So what I would do is I would measure its length, width, and height in centimeters, and multiply those together. If you don't know how to do that, pick a corner of your cube, and since it's a regular shape, you can do this. Pick a corner and measure the edges that go off that one corner, and those are the 3 dimensions. So I did that. And I got, let's see, 5.1 times 1.9 times 1.7. Those are my 3 dimensions. I just multiplied them together, and I get 16.473. So on my paper, I'm going to write 16.473, and this time it'd be centimeters cubed because you did it in centimeters. You could change that to milliliters because they're equal. They're the same thing. You could change that to cubic centimeters. It's the same thing. Then I'm going to do the math on that. And to do the math, I get my calculator out again. And I say 12.5 divided by 16.473. And I get the answer of 0.7589. 0.7589. And to get my units, I literally look at my problem, and it would turn out to be grams per centimeter cubed. So my final answer on that one. Now, the next part. It's asking you to come up with these answers yourself. It shows you the balance. Read it. That would be your mass. It gives you the amount of volume. So you're going to take your mass divided by your volume and get this, and don't forget your unit. On this one, it gives you the balance. It happens to be electronic balance. This one, you're going to have to multiply together the dimensions like we did on the wooden block to get your volume, and then you take this divided by this to get this. Don't forget your unit. This is a balance, like a non-electric balance. It's kind of like you go to the doctor's office and they put you on a scale and they have to move those what they call riders till it balances. Well, you read the riders, you add these up. This one says 100, this one says 60, this one says 7. So it's 167. There's your volume. You take this divided by this and get this. Don't forget your unit. And then the last one, it shows you the whole balance. Read the riders. There's your volume. You read the graduated cylinder. Take this divided by this, get this. Don't forget your units. Then submit.